All right, if you're gearing up for the TKO 3120 Machine Learning and Pattern Recognition Final, you've come to the right place. We're going to build your personal game plan to absolutely nail this exam.
And look, I get it. This course covers a ton of ground, everything from classic pattern recognition all the way to neural nets. So if you're looking at all this material and feeling a little stressed out, that is totally normal.
But the good news is, with the right strategy, you can walk into that exam feeling confident. So let's do this. We're going to break it all down, piece by piece, so you know exactly what to focus on. So here's our roadmap. First, we'll cover the rules of the game, the logistics, and how you're graded. Then, we'll get into the core playbook of must-know theories, followed by the advanced plays with the key models. And we'll wrap it all up with what I think is the most important part, getting into that winning mindset.
Okay, first things first, let's talk logistics and grading. You know, you can't win the game if you don't know the rules. Getting this stuff down pat removes all the guesswork and lets you focus on the material.
So here's how the points shake out. The final exam itself is worth 30 points. That's 5 questions, 6 points each. But, and this is super important, don't forget about your exercise work. That's another 6 points that are basically essential for your final grade.
And here is the magic number you need to remember: 16. To pass the course, you have to get at least 16 points from the final exam itself. Plus, your exercise work has to be accepted, which means scoring at least 1 point there.
The whole process is really straightforward. Step 1, you have to get that exercise work submitted. It's a non-negotiable prerequisite. Once that's in and accepted, you can take the electronic exam. After that, kick back and you should get your grade within about a week.
So, lock these details in. The exam window is pretty wide, which is great. But seriously, don't wait until the last minute. My advice, get your exercise work done and submitted way ahead of time. That way, you can pour all your energy into studying for those 5 big questions. Okay, now that we know the rules of the road, let's get into our core playbook. These are the fundamental ideas that everything else in the course is built on. You've got to know this stuff cold.
First up, Bayesian Decision Theory. You absolutely have to get your head around this. It's all about making the smartest choice when you're not 100% sure, by balancing what you already believe with the new evidence you see. You know, like in the classic fish example, how do you decide if it's a salmon or a sea bass to avoid making the most expensive mistake? That's what this is all about. Next, estimation theory. You're definitely going to be asked about the difference between maximum likelihood, or ML, and maximum a posteriori, MAP. Here's the rundown. ML just tries to find the settings that best explain the data you have. MAP does that too, but it also considers any prior beliefs you have about what those settings should be. It's a subtle difference, but a really powerful one. All right, this one's a biggie, and I can almost guarantee you'll see it on the exam. Overfitting versus underfitting. You have to be able to explain this inside and out. An overfit model is like a student who just memorizes the answers. It aces the practice test, but fails the real one. An underfit model didn't study enough at all. The real art of machine learning is finding that sweet spot right in the middle. And finally, for our core playbook, how do we actually know if a model is any good? You need to know how to evaluate it. Be ready to talk about nested cross-validation, which gives you a really honest estimate of performance. You should also be able to explain what a ROC curve shows, that trade-off between true positives and false positives, and why the AUC is such a neat way to summarize a classifier's overall skill. So, with those fundamentals locked down, we can move on to the advanced plays. This is where we look at the specific models and methods you'll need to know, where you really start applying all that core theory. When it comes to neural networks, the exam is going to focus on the multi-layer perceptron, the MLP. So know its structure and definitely know how it learns using backpropagation. You should also be familiar with the practical side of things, like using weight decay to stop it from overfitting, or using an early stop committee to help it generalize better. Next up, tree-based methods. You'll want to review how a decision tree gets built using splitting rules like the Gini impurity to make the purest possible groups at each step. But the real power comes from ensembles. You need to know how random forests use a technique called bagging to make a bunch of diverse trees, while boosting methods, like AdaBoost, build a sequence of trees where each one tries to fix the mistakes of the last.
Okay, this is another one you have to be crystal clear on. The difference between feature selection and feature extraction. Think of it this way. Selection is like picking the best players for your team from a group of candidates. Extraction is like taking your players and teaching them entirely new, more powerful skills. So you need to know about selection methods, but also extraction techniques, like local binary patterns for textures or moments for describing shapes. And that brings us to our final section, which honestly might be the most important one, because this exam isn't just about memorizing facts and formulas. It's about how you think. It's about adopting the winning mindset that the professors are actually trying to test for.
This quote right here, it's straight from the course summary, and it's basically the key to the whole exam. It's your North Star. They don't just want you to know what a method is, they want you to understand it, how it works, why it works, and what to do with the results.
So here's the big takeaway, the thing I want you to remember. For every single topic we've talked about, from Bayes' theorem to random forests, you need to ask yourself 3 questions. 1. Why does this work? 2. How does it work? Really, step by step. And 3. When would I use this method instead of another one? If you can answer those 3 questions, you're not just memorizing, you're understanding. So there you have it. That's the complete game plan for the TKO 3120 exam. You've got the logistics, the core concepts, the advanced methods, and most importantly, the right mindset. Now the ball's in your court. It's time to build out that study schedule and get to work. You've got this. Good luck.